In this lesson, we will look at the collision theory so as to finally understand the conditions necessary for a reaction to occur. Before we state the collision theory, let us first understand the meaning of collision. Collision is a sudden coming together of two or more bodies. The collision theory, in turn, states that for a chemical reaction to occur, there must be a collision between the reactant particles. If you recall Dalton's atomic theory, you remember that he also postulated that for a chemical reaction to take place, atoms must either combine or separate. The collision theory reiterates this fact, but uses stronger terms. It explains that if particles of reactants do not collide, there is simply no reaction. However, this does not mean that products must be formed whenever reactant particles come together. Far from it. In a chemical reaction, the particles in the reaction vessel collide a number of times, but most of these collisions do not lead to the formation of a product. Only a few of these collisions bring about the formation of a new substance, and those collisions are called effective collisions. A good question would be, why do these collisions not lead to a chemical reaction? To answer this question, we have to talk about the factors that determine the effectiveness of collisions. The first factor is the energy of the reactant particles. Before we explain this, though, we need to understand the meaning of activation energy. Now, activation energy is a minimum amount of energy needed by reactant particles in order to react. So it's just like you trying to go to a bar. If you are not able to prove that you are 18 or over, you will not be allowed in. In a similar way, if the reactant particles have not acquired sufficient energy to break existing bonds so that new bonds can be formed to make products, there can be no reaction. That energy that must be acquired for the bond to be broken and a new one to be formed is called the activation energy. Each reaction has its own activation energy. So if the individual particles collide without acquiring energy equal to the activation energy for that particular reaction, there will be no reaction. For example, in the reaction between carbon and oxygen to form carbon 4 oxide gas, the carbon atoms must acquire enough energy to first break the diatomic oxygen molecule and then form new bonds with the oxygen atoms that were formed. This reaction requires the input of energy in the form of heat because the covalent bond holding the oxygen atoms together requires a lot of energy to be broken. So carbon and oxygen left in a container will collide, but there won't be any effective collisions because they need to achieve the activation energy of the reaction before they can form products. There's another factor that determines the effectiveness of collisions, but we will discuss that in the next lesson. For now, a simple summary of this lesson is, for a chemical reaction to occur, there must be a collision between the reactant particles. An effective collision is one which leads to a chemical reaction. Activation energy is the minimum amount of energy that must be possessed by reactant particles before a reaction can occur. I'll see you in the next lesson.